Hey, we're here at go2math.com. Let's click on the calculus. Go down to related rates 9-3. There we go. Find the rate of change of the distance between the point 25 and a moving point on the graph of y is equal to square root of x plus 4 when x is equal to 7 centimeters and dx over dt is 3 centimeters. So let's take a second here and write down these numbers. Now this one's different compared to the others. This will be a little bit more difficult. I mean, not by much, but because this point is somewhere out in the plane and it's not at the origin, so it's somewhere out there. Somewhere out there. Alright, and if you haven't worked 9-1, you should go back and work 9-1 and probably 9-2 before you work this one. I highly suggest it. Yep. And let's use a different color like blue or something. Okay, so we have y is equal to the square root of x plus 4. We got some point in the plane, 2, 5. And what else we got? They gave us x is equal to 7. They gave us dx over dt. I say they, I don't know what, the internet, cyberspace, 3 centimeters per second. I left that out, centimeters there. I don't want to forget that. Okay. All right. Okay, well, we're just going to trust the math on this. In other words, we're not going to draw any pictures. X of 2 minus x of 1. We're going to follow the procedure here. Y2 minus y1 squared. So the first thing we want to do is take the derivative of this. So this is 2d times dd over dt, 2 times x of 2 minus x of 1, and this is dx over dt plus 2 y2 minus y1, and this is dy over dt. Okay. Alright, so let's see. First off, we need to identify our ordered pairs, and we'll just do that right here. We have x of 1 and y of 1. Who's that going to be? Well, that's going to be, let's let that be this point here, okay? So 2, 5. And then we're going to need our x of 2 and our y of 2. And they gave us what that x value is going to be, and that was 7. But now to find y of 2, we'd end up plugging that into to get our y value. We're going to plug that right into here. Okay, so that's not going to be very nice, is it? Was x 7 centimeters? I guess it was. That's not going to be nice. So we plug that in, we get the square root of 7 plus 4. Alright, that's going to be our y of 2. Alright, so we got a 2's in each one of these terms here. We can multiply through by a half all the way across, and that will cancel them out. And I'm going to rewrite, so d, and we're just going to go through and plug everything we know. Actually, what we don't know is our dy over dt. Alright, I'll do that here in a second. X of 2 minus x of 1. So x of 2 is 7 minus 2. So that's 7 minus 2. And then dx over dt, that was something they gave us, and that was 3 plus, and then we've got y of 2, which is this guy, minus 5. That's not very nice, is it? Square root of 7 plus 4 minus 5. Man, got nasty numbers this time to be dealing with. Dy over dt. How do we find dy over dt? Well, we start with y is equal to, and I'm going to actually write it like this, and then plus 4. To find dy over dt, we just take the derivative of this. We got dy over dt is equal to a half times x to the negative a half, and then the derivative of a constant is 0. Now I'm going to rewrite this as dy. Oh, you know what? I almost messed that up. Dx over dt. I just about left that off, didn't I? You got to be careful about that. So dy over dt is equal to, so this is going to be 1 over 2 times the square root of, we're going to go ahead and just plug our numbers in, x, which was 7, right, x, which was 7, and then dx over dt, which is 3. So dy over dt is equal to all that nice, lovely bunch of mess. So 3 over 2 square roots of 7. Yikes. Okay. We're going to need to rewrite a lot of this. We're going to rewrite it. Okay. So down here, we're up here looking at this. So this is what we want to rewrite. And actually, I'm going to do it like this. I'm going to go ahead and take this d diagonally down below. So dd over dt is equal to, we have 7 minus 2, which is 5, and 5 times 3 is 15. We might as well just get that out of the way. Plus, and now we've got 4 minus 5 is negative 1. So we're going to be left with the square root of 7. It looks like minus 1. Alright, and it's multiplied by 3 over 2 square roots of 7. Boy, that is just ugly. And then, of course, this is all over d. And remember what d is. D is the square root of. Now, we've got, we come up here and look at this, okay? Because basically what we're going to do is take this. This is our x of 2 minus x of 1, which happens to be, we might as well just go ahead and rewrite this. This happens to be 5. So this is 5 squared plus, and then this turns out to be our y of 2 minus our y of 1. But then we can reduce this down to the square root of 7 minus 1, and that's quantity squared. So now what we'll want to do is just kind of plug all that stuff in, and then hope that everything is correct, and I'm sure that it probably is. So anyway, let's take a look at this. We have 15 plus parentheses square root of 7 minus 1 times 3 divided by, it looks like 2 times the square root of 7. Alright, for the top part, and it's definitely ugly, divided by the square root of 25. Boy, I sure hope this is all right. We got the square root of 7. Hopefully you're calculating this yourself, seeing what you come up with. hit enter, hold my breath. Oh man, I sure hope this is right. D over dt is approximately, and we round 2 decimal places, I'm getting 3.026, so 3.03, and of course this is centimeters per second. Centimeters per second. And if it's not right, I'll be deleting this video and having to redo it again. Oh my god, thank God. Tell you what. Anyway, dd over dt is 3.03 centimeters per second. Like a friend of mine once said, that's a frickin' miracle. I was helping somebody one time, it was about midnight, and they had a college algebra test the next day, and we went through using the slow. I mean, it was something fairly simple, but it took about 10 steps, and they yelled up, was inside this computer lab, and they stood up and yelled all the way across the computer lab and said, that's a effing miracle. Anyway, okay, well, there it is. You need to come on over and practice, and I'll see you there. Bye.